Okay, so you're going to see a few types of problems. I know, it's fun. We get recorded. Guys, I'll wait. Okay, so when you see these types of problems, there's a few steps that I would ask you to go through. When you see a problem involving distance, rate, time, or involving mixture, Max, guys, can you stop the talking? You want to make sure that you define what you're looking for. So number one says, a woman rows a boat upstream from one point on a river to another point 4 miles away in 1.5 hours. The return trip, traveling with the current, takes only 45 minutes. How fast does she row relative to the water? And at what speed is the current flowing? So we're looking for two things here. We're looking for the woman's rate that she rows. It says how fast does she row? And then we're also looking for the speed of the current. So let's define W as the woman's rate for rowing. And we'll define C as the rate of the current. Now we also might want to define a few other things here. Because if we look at the problem, it says a woman rows a boat upstream. So upstream, she's working exactly right, against the current. So I need to keep in mind that she is going against the current in one part of the problem. So how would I represent in terms of W and C what's being described there? Joseph? Negative C plus W, maybe? Yeah, Joseph, exactly right. If the current is working against you, it's subtracting from your rate. So we could take a look at this as W minus C would represent the current working against the woman. Working against the woman's rate. The second part of the problem says that the return trip, traveling with the current. So how would we define, in terms of our variables here, the rate with the current? Yeah, so W plus C would be the rate of the woman with the current. So these are types of things you're going to want to define when you see like a rate of flow. Either like a plane flying against the wind or a boat working against the current. These are just kind of things to think through. And now we want to set up our system that we can use to solve. So looking at my system here, what's being described, let's reread this first sentence. It says a woman rows a boat upstream from one point on a river to another 4 miles away in 1.5 hours. So I'm looking at a rate, which I've defined, in terms of distance and time. What is the ultimate equation that we've learned involving distance, rate, and time? Zach? Yeah, exactly right. Distance is equal to rate times time. So now let's go ahead and let's just fill in these pieces based off of the variables we've defined. So it says the distance is 4 miles away. So I can put 4 in for the distance, equals, and this is 4 miles away, which is being described upstream. So what am I going to put in for R for upstream? Max? W minus C. Good. That would be upstream rate. Kind of. We've done systems of linear equations. It's just we haven't done with these quite level of difficulty yet. So we have W minus C times how long does it take for her to reach those 4 miles distance working against the current? 1.5 hours, so 1.5. Now we have 2 variables, so we want another equation because we need to be able to solve. So the next part of the problem says the return trip traveling with the current takes only 45 minutes. What would be the distance of the return trip? 4 miles, yep, same thing, is equal, what would be our rate with the current? Yeah, W plus C times, it says the time is 45 minutes. Can I put 45 in? No, I have to work with 3 over 4, or 0.75, because 45 minutes is 3/4 of an hour. So 0.75 hours. We want to make sure our units are consistent. Okay, now you have different options you can use, but this is your system that you would want to go about solving. Some people would like to multiply the top equation by 10, just to get rid of the decimals, and the bottom equation by 100. Others might just want to work with the decimals and just start distributing right away. What do you guys want to do? Just distribute? Okay, so if we distribute, there's no real wrong answer or right answer. We would have 4 is equal to 1.5W minus 1.5C. And the second equation would be 4 is equal to 0.75W plus 0.75C. So here's my system. The numbers are nice and lined up, so elimination might be a nice one to use. If I was focusing on the variable C, what would I multiply the second equation by in order to eliminate C? Multiply by 2. Good. So if I multiply this equation here, the left side and the right side by 2, that would give me 8 is equal to 1.5W plus 1.5C. And then if I recopy that first equation down here so I can use it with the elimination, I have 4 is equal to 1.5W minus 1.5C. And we know with the process of elimination, you add straight down. So 8 plus 4 would give me 12. 1.5 plus 1.5 is 3. C is well eliminated. So divide by 3, and I would have W is equal to 4. What does W stand for? The woman's rate. So what's the woman's rate? Yep, 4 miles per hour. And then what can I do to solve for C, the currents rate? Plug it back in. And we can plug it into any. I'll just go ahead and take this equation. So 4 is equal to 4 minus C times 1.5. We could divide both sides by 1.5. And here I would want to multiply by 10 over 10 just so I can not use any rounded answers. So that would be 40 over 15. And 40 over 15, does that reduce at all? By 5? Yep. So that would be divided by 5, 8/3. 8 over 3 is equal to 4 minus C. Subtract 4 from both sides, so 8/3 minus 12/3 would give me negative 4/3 is equal to negative C. So what would the rate of the current be? 4/3, or we'd probably better say that as 1 1/3 miles per hour. So there would be our currents rate, and there would be our woman's rate, 4 miles per hour. Okay, again, I do want to try all of these types of problems. Number 2 is very much like number 1. So what I'd like you to do is just set up the system you would use to solve with your partner. So just set up the system. Okay, guys, a lot of you are going on to solve, which is awesome. I just really want to see if you can set up the system. I think you all know how to solve. So hopefully you had 580 equals the plane plus the wind's rate as a whole times the 5 hours. And 580 equals the plane minus the wind's rate multiplied by 10 hours. Any questions on that? Okay, let's go to the second type of problem. The second type of problem that you will often see when working with linear systems is a mixture problem. So let's read this through and then we'll see how to define our pieces and then put it into equations we can use to solve for. It says a biologist has 2 brine solutions, one containing 5% salt and another containing 20% salt. How many liters of each solution should he mix to obtain 1 liter of a solution that contains 14% salt? So one thing to be aware of is there's really 2 pieces we're looking at. We're looking at how much of each solution and then how much salt should be in that solution. Well, we could call him Mr. Mack. He'd probably know what to do. But if I'm looking at the two brine solutions, let's just define those brine solutions. So X will be the amount of solution containing 5% salt and we'll call the second solution Y is the amount of solution containing 20% salt. 20% salt. And then just so you're aware, this is kind of like the adult and children problem that you guys had in last night's homework when you were looking at the amount of adults and children equaling 2,200 versus the value that the children brought in was $1.50 per child and the adults was $4 per child reach the value. Well, when you're looking at how much salt, 0.05x represents the amount of salt in the X solution. So 0.05x represents the amount, and really the 5% amount of salt in the solution. And then 0.20y, 0.2y is the amount, which is 20% of salt in solution Y. Okay, if we define our pieces in this way, we should be able to come up with two equations that will help us navigate our solution. Jacob?
I just have a question. What are the equations?
Oh, amount. I could just write it in there. Probably should. Amount. Okay. So how much total solution are we looking for? It says how many liters of each solution should he mix to obtain 1 liter of a solution? So how much total am I looking for? 1 liter. So the amount of X plus the amount of Y has to equal 1 liter. Now our second equation says he wants to obtain a mixture of 14% salt. So how would I set up the second equation to solve? Zach? Well, plus 0.2y, right? The amount of solution containing 20% is going to equal 0.14, 14% salt. So I'd say 0.14 of the 1 liter. How much salt does he want in the 1 liter? Well, 14% of salt. So 14% of 1 liter. I'm not sure how many milliliters that would be. So this would be the solution that you, or the system that you would be using to solve. And you would go on, probably, in my opinion, actually, we could probably solve this pretty easy. These are already lined up. What would you want to multiply the top equation by in order to eliminate X? You would,
By 5.
you would multiply the bottom by 5?
Negative 5.
-5 to create
What?
the 1y. So you would eliminate y. We could do that. But if you multiply the top one by 0.05, you could do it that way as well, by negative 0.05 to eliminate x. So it's kind of whichever you see. I guess I saw x first. That's why I said if we multiply the whole thing by negative 0.05, then that would create a negative 0.05x minus 0.05y is equal to negative 0.05. Add straight down. So 0.20 minus 0.05 would give us 0.15y is equal to 0.14 minus 0.05 would give us, what is that, 0.09? Yes? 0.1, sometimes yep, 0.09. Divide both sides by 0.15. And that would give me y is equal to 0.6 of a liter. So we should have 0.6 of a liter containing the 20% solution. And then if we use substitution, we can do x plus 0.6 has to equal 1. So X would have to equal 0.4 liters in order to obtain the amount of salt you want in the mix. Indeed. Okay, take just a, well, actually, to be honest, we're going to skip this example. Remember how I said we might not get to all of them? I want to go to number 5, just because number 5 can look a little tricky. It's actually easier than the other problems. So let's read through it, and we'll take a look at how you can see it as an easier problem. It says, a manufacturer of soft drinks advertises their orange soda as naturally flavored, although it contains only 5% of actual orange juice. A new federal regulation stipulates that to be called natural, a drink must contain at least 10% fruit juice. How much pure orange juice must this manufacturer add to 900 gallons of orange soda to conform to the new regulation? So we're actually only solving for one variable here. If I call X the amount of pure OJ, that's all I'm looking for, is how much pure OJ needs to be added to the mix. So X, we're going to look as the amount of pure OJ how many current milliliters do we have right now? 900 gallons, right? So, shh, Max. I know how much OJ is in that 900 gallons. Currently, how much OJ is in the 900 gallons?
5%.
Just 5%. So what's 5% of 900? We could figure that out. It means 45 milliliters right now is currently the amount of OJ in that 900. I want to see how much pure OJ can I add to create 900 plus an additional amount containing 10% orange juice. So this is really what I'm looking at. I'm looking at the 5% of OJ in the mix plus how much 100% OJ do I need to add to the mix to equal 10% of the total mix. So what I have right now is I have the current amount of 5% of OJ. I have 0.05 times 900 gives me, what we'll find, 45 milliliters of pure OJ is currently in the mix. And I want to see how much OJ do I need to add. So 100% would be 1 times X, how much pure OJ would equal 0.1 times the current total plus however much I add would give me that total value. Now this one takes a little bit of thought to kind of mull over, and that's what you're going to do more in your homework tonight. But really you only have one variable that's really necessary to work with. So if we solve here, we have 45 milliliters plus X is going to equal, I'll distribute this, 90 plus 0.1x. And then we can just go on to solve. So if I subtract 45 and subtract 0.1x from 1x, or 1.0x, then I will get 0.9x is equal to 45. And take 45 and divide it by 0.9. And I get that I should be adding 50 gallons. 50 gallons of pure OJ. 50 gallons. 50 gallons of pure OJ. All right, I'd like you to see if you can set up number 6. See if you can set up number 4's system if you feel like you're confident in setting up number 6.